Hello, grade 12. Welcome back to the channel Science Therapy. In today's lesson, we're going to be looking at geometric sequence. And without any further ado, let's look at these questions that we have here. So it says, given all this pattern here as a geometric sequence and where x is not equals to 2. So why are they saying x should not be equals to 2? It's because if you can go ahead and substitute 2 here, you will get this whole expression as 0, because remember, 2 minus 2 is just 0, and then if you multiply it with that 16, it's 0. Even here, you'd get this as 0 and that as 0. So because you'll have all your terms as 0, that means you won't end up having a constant ratio. So that means this will no longer be a geometric sequence. So for that reason, x should not be equals to 2. Right. Okay, so now let's proceed. We have question 1. It says, determine the general term of the series in terms of x. So in order to determine the general term of the series, we need to, of course, remind ourselves of the formula Tn is equals to a r n minus 1. So this is the formula for the general term of the geometric series. Right. Then what is our a? We know that our a should always be the first term. So let's substitute. This is 16x minus 2 and then cube, right? Because we are writing it in terms of x. So we are writing all this as it appears. Then what is our r? In order to find our r, we know that we need to say r is equals to T2 divided by T1, right? So our T2 is 8x minus 2 to the exponent of 4, and then this is 16x minus 2 to the exponent of 3. So now we can see that 4 of this, there's 4 of this, and then there's 3 of that. So 3 of this will cancel with the 3 that we find in here. Then what is 8 divided by 16? We know that that's 1 over 2. So we can just say up there we are left with x minus 2. Then down here we are only left with 2. So our r is x minus 2 over 2. Right. So this is our r. Let's substitute it here. That's x minus 2 over 2. And then all to the exponent of n minus 1, right? All to the exponent of n minus 1. Okay, then that's how we would have our general term in terms of x. So you just leave it like that, right? Okay, so now let's proceed. Question number 2 says, calculate the value of x for which the sequence converges, right? When we speak of a convergent series, this is where our r should be in between -1 and +1. So a series would converge if our r is anything between -1 to 1. So your r can either be -0.5, -0.6, as long as it's within these two values here. Then it should not be -1, it should not be 1, but it should be a value that's in between. Right. So, okay. Now, in order to do that, we already have the value of r. We calculated it to be x minus 2 over 2 from saying T2 divided by T1. Right. So we got x minus 2 over 2. Now, what you should do is just put this in between this formula here. So you have -1, and then what's your r? It's x minus 2, and then you have over 4 here, and then you have your 1. Then what do you do? Okay, not 4, it's 2. Let's fix here. So we have x minus 2 over 2. There we go. Then what we should do is cross multiply with this 2 here. So this -2, and then we have x minus 2, and then here we have +2. Then at this point we take this -2, transpose it over to this side, and again transpose it over to that other side. So that's -2 plus 2, and then here we are left with x, and then there that's 2 plus 2. So this will be 0, and then x less than 4. So this is x greater than 0, but x less than 4. So in order for this sequence to be convergent, right, or in order for this sequence to converge, your x value has to be anything between 0 to 4. So it should not be 0 and it should not be 4, but then it should be a value that's in between these two critical values. Right. Now look at the following question that we have. says determine the sum to infinity of the series if x is equals to 2.5. Now you can see that in the previous question we concluded that our x should be between 0 to 4, and then now they're giving us a value 2.5, which is definitely between 0 to 4, right? So now they're saying calculate the sum to infinity. So we know the formula to calculate the sum to infinity. We just write it like this. This is sum to infinity, and you say a over 1 minus r. Then you must indicate here where your r should not be equals to 1. Why your r should not be equals to 1? Because if you say 1 minus 1 here, this will be a non-real value or an undefined value, right? So what's your a? Your value for a is 16x minus 2 to the exponent of 3. But then remember, we already have the value of x, so we can calculate a by saying 16, and then where there is x we substitute 2.5, then we say minus 2 to the exponent of 3. Now at this point you just grab your calculator, 16 and then 2.5 minus 2 to the exponent of 3, then this gives us a is equals to 2. Then let's go ahead and substitute here. We have 2 over 1 minus our r. Remember we found r is as x minus 2 over 2. So we can calculate the value of r by substituting the value of x here. This is 2.5 minus 2 over 2. Then let's quickly punch that in our calculator. 2.5 minus 2 divided by 2. That gives us r is equals to 1 over 4, right? Which 1 over 4 can be written as 0.25, right? So that's 1 minus 0.25. Right, so punching the sum to infinity, so sum to infinity is 2 over 1 minus 0.25. Let's punch that, 2 over 1 minus 0.25. That gives us a value of 8 over 3. So that's our sum to infinity. Or if you wish, you can write it in decimals and then just SD that. This will give us 2.67. So that becomes your sum to infinity for the series that we have here. And yeah, okay, then we have activity number 3 here. It says given the geometric series is 24 over x plus 12 plus 6x plus 3x squared plus a whole lot of values. So this series is going all the way there to whatever value we don't know. Then we are given question number 1. If x is equals to 4, then determine the sum to 15 terms of the sequence, right? So we are given that if x is equals to 4, that means we have to create this sequence or this series here, substituting 4, right? So if we say 24 divided by 4, that's going to give us 6, right? So we have 6 plus 12. If we say 6 times 4, that's 24. If we say 3 times 4 square, that's equals to 48. So that means our geometric series would be this if our x is equals to 4. Now it says determine the sum to 15 terms of the sequence. Now the formulas that we have for sum of a geometric series are a1 minus rn over 1 minus r, or this one here, a rn minus 1 over r minus 1. So for both of them, r must not be equals to 1, r must not be equals to 1. Now how do we get to decide which formula we need to use here? Let's first find our r, right? Our common ratio or our constant ratio. So we say T2 divided by T1. This would give us 12 divided by 6. So our R would be 2, right? So even if you say 24 divided by 12, still gives you 2. Now that we have our R is 2, then we need to decide which formula is best suited for us to use. Now understand this. The first formula that you are seeing here, you only use it if your R is less than 1. So why? Because we want our denominator to always be a positive. So here if we have R being anything less than 1, then it's best to use this formula because, for example, let's say we have 0.5. 0.5. This would be 1 minus 0.5. It will still give you a positive denominator. But what if our r is greater than 1, as with this case here? This is the formula that is most suited for that one, because for example we have 2 here. This would be 2 minus 1, and then still would have a positive denominator. So the goal here is to have a positive denominator. So you use this formula here if your r is less than 1. You use this formula right here if your r is greater than 1. So know when to use these formulas. They are quite similar, but then just a matter of this one is 1 minus r and that one is r minus 1. Okay, so now we've concluded that the formula that we need to use is the second one here. So let's go ahead. We're gonna say sum to 15 terms now is a and then rn minus 1 over r minus 1, where your r should not be equals to 1. So what is your a? Your a value is 6. Remember, we found 6. Then your r is 2. Then for n, we're just going to go ahead and substitute the 15 because that's the number of terms. Then we have r is 2 minus 1. Then at this point, all you need to do, guys, is just simply punch this in your calculator. Then 6 bracket 2 to the exponent of 15 minus 1. And then close bracket 2 minus 1. So if you punch all that in a calculator, gives you this big number here, which is 196,602. So guys, it is quite normal for you to get such big numbers when you are dealing with a geometric series. This should not in any way intimidate you, right? So this is to be expected even having a number that is way bigger than this one, or having a very smaller number if it happens that your geometric series is convergent. Remember, if it's convergent, that means it will decrease all to a lower value. But then if we have a bigger value like that, that means your geometric series is actually divergent. It is increasing, which is the question that they're asking us here. They say, okay, let's solve this one too. Determine the values of x for which the original series converges, right? So now they want the values of x for which this series will converge. So how do we do that one? Remember, when they're talking about the original series, they mean before you make x 4, right? So we made x to be 4 in the first question, but then here with number 2, we are solving this in terms of x, right? So we haven't substituted our x. Then this would be r is equals to t2 divided by t1. That means our r would be 12 divided by 24 over x. So this would obviously be 12 multiplied by x over 24. If we do tips and times, then how many times does 12 go into 12? It's once. Then how many times does it go to 24? It goes twice, right? So 1 times x, it's 1x, and then over 2, so that's 1 over 2x. So that's your value for r. Your r is half x, or even if you did it with this one, t3 divided by t2, so you'd say t3 divided by t2, this would be 6x divided by 12. Then this would be half x. So still you'd get your r value as half x. Now if you have your r as half x, remember, in order for a series to converge, we said your r must be in between -1 and 1. So r must be an element of -1 to +1. So what do we do at this point? You just say -1. Then where there is r, substitute your r in terms of x, which is half x, and then we have 1. Now at this point you want to get rid of this 2. So how are you going to do that? You can multiply both sides here by 2. Right, so this 2 will say 2 times -1, that's -2, but then the 2 will multiply with this half x, so you are left with x. Then the 2 that will multiply with this, so that's 1 times 2, that's 2. Right, so in order for this series to be a convergent series, your x value must be in between -2 and +2. So x must be an element of -2 to +2, so that your series is convergent. Right, okay, so what does it mean for a series to be convergent? It means that this will be a decreasing a decreasing geometric series, right? Okay, so now let's look at number 3. Number 3 says determine the values of x for which the original series will be increasing, right? So we want to determine the values of x for which the original series will be increasing. Now we've concluded that if a series is converging, that means it is decreasing. And then we said this is when x is an element of -2 all the way to +2. So if we are saying that for these values, the series is convergent, right, or converges, that means this series would actually diverge for all the values that are not within these critical values. So that means the series diverges for x less than -2 or x greater than 2. Right, so if x is not an element of -2 to +2, that means x is less than -2 or x is greater than +2. So these are the values that would actually give us the values of x for which the original series will be increasing, right? Okay, so if we were to substitute a number that is greater than 2, let's say maybe let's substitute x as 3, for example, then this is what we would observe. We would see that if we say 24 divided by 3, that would give us 8. Then this would be 12. If we say 6 multiplied by 3, this would be 18. And then if we say 3 bracket 3 square, this would give us 27. So what is it that we are seeing from this series is that the series will keep on increasing, right? So the series keeps on increasing. But then let's look at this. What if we substitute a number that is actually within this critical value? So we want to see if we substitute, let's say for example 0. Okay, let's not substitute 0 because this will just be undefined. Let's substitute 1, right? So if we substitute 1, this would be 24, and then 24 divided by 1 is 24. Then this is 12, then this is 6, and then this is 3. Now note this. You can see that the series now is converging. It's becoming smaller and smaller, right? So if the values are within these critical values, then your series converges. But if the values are outside the critical values, then your series diverges, right? Meaning it increases. So convergence means the series decreases, and then divergence means the series increases. So that's it, guys. Okay, so let's look at activity number 4. It says given 2 and -1 as the first two terms of an infinite geometric series, calculate the sum of this series, right? So now we are given 2 and then followed by -1, and then we are told that this is an infinite geometric series, right? An infinite geometric series is a geometric series that does not come to an end. So in order to calculate the sum of an infinite geometric series, you obviously have to use sum to infinity, right? So now let's calculate r. Our r we know is t2 divided by t1, so this would be -1 divided by 2, which is -1 over 2, right? We already have the value of a is 2, so let's calculate sum to infinity is equals to a over 1 minus r, where we need to say r should not be equals to 1, right? So what is your value for a? Is 2, and then 1 minus a -1 over 2, right? Then that's all that you needed to do. So this is 2 over 1 minus a -1 over 2, right? And then this is equals to 4 over 3. So that's your sum to infinity. So all that you needed to understand here is the word, if they tell you that it's an infinite geometric series, that means you have to use sum to infinity, right? So that's all that you needed to understand there. Okay, then activity number 5 says the following information of a geometric pattern is given. We are given that t1 plus t2 is equals to -1 and t3 plus t4 is equals to -4. Now I want to show you something. Suppose that you have this formula here to calculate the general formula of the geometric series. if you wanted to calculate T1, you'd say this is AR and then you say 1 minus 1. So your T1 would end up being AR to the exponent of 0, which we know any variable or number expressed to the exponent of 0 is equals to 1. So that means your T1 would only be A, because A times 1 is A. Suppose you wanted to find T2, you would say this is AR and then you'd have 2 minus 1. So your T2 would end up being AR. Then your T3 would be AR and then 3 minus 1. So your T3 would be AR to the exponent of 2. Now, if you already see the trend, look at this. If you are looking for T2, then you have R to the exponent of 1. If you are looking for T3, you have AR to the exponent of 2. That means T4 would be what? AR to the exponent of 3. Now, if we can even play along with it, your T100 would be what? AR to the exponent of 99. So this will come in handy, guys, to understand this, because when you are given this, when you are given questions like this, they require you to change this and write it in mathematical form. So it is very crucial that you understand how to actually change this expressions into expressions like this, right? So let's try to solve using that. We have T1 plus T2 is equals to negative 1. So we want to express T1 plus T2 as A plus AR, and then it's equals to negative 1. Let's call this equation number 1. So bear with me and you will see what I'm trying to do here. Then T3, this would be expressed as AR to the exponent of 2, and then T4 would be AR to the exponent of 3, then it's equals to negative 4. Let's call this equation number 2. Now at this point, looking at this, let's deal with expression number 1 or equation number 1. We can see that A here is the common factor. So let's factor out the A and then we'd be left with 1 plus R is equals to negative 1. Now let's decide to make 1 plus R the subject of the formula. So we're just going to divide both sides by this A. Then we have 1 plus R is equals to negative 1 over A. Let's call this equation number 3. Now let's work with equation number 2 here. So the common factor in equation number 2, as we can see, is AR squared. If we factor out AR squared, we are left with 1 here. Then we are left with only R. So if we take out AR squared here, because we have R cubed, then that means we'll be left with this R here, then negative 4. Now let's also make 1 plus R the subject of the formula. So let's divide both sides by AR squared. So that means we have 1 plus R is equals to negative 4 over AR squared. Then let's call this equation number 4. Right, let's equate equation number 3 and equation number 4. As we can see, they're both expressed with this being the subject of the formula 1 plus R. Right, so because we can see that all equals to 1 plus R, that means we can equate these two expressions. So we're just going to go ahead here and write equate equation number 3 and equation number 4. Right. So what do we have? We have negative 1 over A is equals to negative 4 over AR square. Right. Then here we need to cross multiply, right? So negative 1 times AR squared, that's negative AR square. And then we have negative 4 times A is negative 4A, right? So let's divide both sides by negative A. Divide both sides by negative A, then our R squared would be equals to 4, right? Then if we square both sides, then our R is equals to plus minus 2, right? But then how would we know which one to choose? Let's look at this. Remember the question we are answering. Determine the following numerical values for the first three terms if R is greater than 0, right? If R is greater than 0 means R must be positive. So we have R is negative 2 or R is positive 2. So that means the only true value is R is equals to positive 2, because they said R must be greater than 0, right? So, but then we haven't determined the first three terms. So in order to determine the first three terms, we need the first term first. So we can substitute the r here to any equation. Let's substitute in equation number 3. So that's 1 plus 2 is equals to negative 1 over a. 1 plus 2 is 3, and then it's equals to negative 1 over a. If we cross multiply this, that's equals to 3a is equals to negative 1. Divide both sides by 3, then my a is equals to negative 1 over 3. Now, if I have my a as negative 1 over 3, that means, considering that r is 2, that means my 3 terms will look like this. I have a is negative 1 over 3. If I multiply by 2, I must get the second term, right? So remember, in order to get the next term in a geometric series, you have to multiply by the common ratio. So negative 1 over 3 multiplied by this r here, which is 2. So I will have negative 2 over 3. And then also again, I take this negative 2 over 3, multiply again by the common ratio. This will give me negative 4 over 3. So now using the common ratio here, I've found the first 3 terms, right? So it's negative 1 over 3, negative 2 over 3, and also negative 4 over 3. Right. Number 2 says determine the nth formula, right? So to get the nth formula, this is Tn is equals to AR n minus 1. What is our A? We calculated negative 1 over 3. Then what was our R is 2. And then we have n minus 1. So that's all we needed to do for our Tn. Right.